Any question on the last part? Have you understood why we are having the point of incidence and point of reflection same? If we don't go for it, what would happen? Then it will not obey the property, light travels in a straight line. What do you mean by straight line? So is it clear now? So are you aware that when we were writing this particular statement, I have written the statement because light travels in a straight line, the thought didn't come to you about the shortest distance path. Am I true or not? So you should get connected with the thoughts. That is the reason why I have drawn this figure. So is figure correct or incorrect? Is this figure correct or incorrect? Which part is incorrect? Which part is correct? ABCD is and EDC is. Getting the reason for that? Why we are drawing the, why we are measuring the angle of incidence and reflection with respect to the normal? There will be an issue in case of irregular polished surface. To avoid that part, we have taken normal as a reference point. Do you agree with that? So, if a light of wavelength lambda is incident on a plane mirror, the reflected light, will it have the same wavelength or different wavelength? If a light is incident and the incident light is having a wavelength lambda on a plane mirror, after reflection, will it be reflected with the same wavelength? Will it be reflected with the increased wavelength? Will it be reflected with a decreased wavelength? Will it be reflected with the same wavelength? How many of you feel decrease? Raise your hand. Good. Why do you feel it will decrease? Reason? No reason, सिर्फ gut feeling है. Why are you feeling that it will decrease? Why others are feeling that it will be the same wavelength? Yes? It is getting 100% reflected, that is a different story. My question is related to wavelength. A light is incident on a plane mirror with a wavelength lambda. On reflection, will it be having the wavelength lambda or will it be having some different wavelength? Light is 100% reflected, no doubt about it. Will it be reflected with the same wavelength or will it be reflected with a different wavelength is a question. Yes, please. Yesterday we have shown it clearly. Color is represented by frequency, not by the wavelength. कल पढ़ा है नहीं पढ़ा है? Then, after reflection, will it have the same wavelength or will it have a different wavelength? Why it should have a different wavelength? I'm not giving you a choice कि either you select this or that. You have to reason for that कि why you are selecting this and why you are selecting this. Why the wavelength should decrease? It's a mirror which reflects 100% of the light incident on it. So there is no question of absorption. Nobody is having a doubt. It is a plane mirror. Then will the wavelength be remaining same or will it be different? Same. So do you know under what condition the wavelength changes? Why the wavelength change? We are talking about mirror. So you should be responding with reference to the mirror. Not with respect to concave mirror, convex mirror. Not with respect to the lenses. Only the plane mirror. That is why I am asking you under what condition the wavelength changes. Yesterday you were telling me the answer and today you are not aware of. You are telling me that when a light is traveling from rarer medium to the denser medium, the light bends towards the normal. When it is traveling from denser to the rarer, it is bending away from the normal. There we have yesterday said that the refractive index depends on the ratio of wavelength. It is independent of frequency. And that is why color has been associated with a frequency. Yaad hai aapko? Do you remember that? So we are talking of the same thing that we are having here, the wavelength that is changing on account of change of medium. So is the incident ray traveling onto the mirror, getting reflected back from the mirror, is the medium changing? Is the medium changing? Are you understanding what I am saying? Is the medium changing or not changing? So if the medium is not changing, will there be a change of wavelength? So that was the answer there. Wavelength will not change. Incident light is made incident on a plane mirror with a certain wavelength. On account of reflection, the wavelength is not changing because the light is still remaining in the same medium. Suppose I call this region to be that of air. This is the part of air. The light is traveling from air, from the surface of the mirror. It is getting reflected here. Light is back in the same medium that is called as air. So if the light is going to remain in a air, the wavelength will be remaining same. The wavelength will not change. Will the frequency change? Frequency? बोलिए frequency change होगा? Frequency will not change. In case of refraction, the frequency is not changing. In this case also, the frequency is not going to change. So wavelength and frequency is not changing. Is the velocity of the light, incident light and reflected light, going to change? Velocity of incident light and reflected light, will it be changing? So it will be remaining constant because medium is remaining, right? What about intensity of light? Why it should remain same? Correct, very true. If you are saying that, ideally speaking, mirrors are reflecting 100% of light incident on it. If it is 100% reflecting, then intensity will be remaining same. But if it is 95% reflecting, then intensity will decrease. If it is 90% reflecting, then 10% of its energy is lost. So you will find that intensity will be decreasing. In reality, you will find that intensity of the image is less than the intensity of the object. Because in real sense, 100% reflectivity is not observed. Theoretically, हम बोलते हैं, we are talking theoretically that you are having the mirror which has 100% reflectivity. But this is not 100% reflectivity. Ordinary mirrors are able to reflect up to 90%, 95%. So there is a decrease in the intensity of light. Are you getting me? What about amplitude? Amplitude, will it be remaining same or decreasing? Under what condition it will be same? Under what condition it will be changing? If your mirror is 100% reflecting, then amplitude will be remaining constant. If the mirror is 95% reflecting, then intensity decreases. Intensity is directly proportional to the amplitude square, so amplitude will also be decreasing. It will depend upon the type of mirror. Got my point? Got my point clearly? Now you are aware that when a light is incident on a plane mirror, it gets reflected back. If angle of incidence is 0, what will be the angle of reflection? Able to get that? Are you all aware of it? Okay. Now suppose I am having a transverse wave. Light is a transverse wave traveling and striking the mirror. Then on reflection, will the phase be remaining constant or phase be changing? Do you remember we have talked that of all physical quantities involved in a wave? So one of the term there was phase, right? So on account of reflection, will the phase be remaining constant or will the phase be changing? Will the phase of the wave be remaining constant or will it be changing? Constant. Why do you think it is constant? So wavelength is not related with the phase. Phase is representing the state of oscillation. Agreed? So have you studied that particular topic of oscillation and waves where you are having the transverse wave or a longitudinal wave incident on a denser medium, on a rarer medium, and study the effect of reversal? So if that is not studied, then only you can remember that एक simple सी चीज है. You can think like this. This is a mirror in front of you. The light is traveling in this direction towards the board. On reflection, what will be happening to the direction of the wave? Right? Light is incident on the mirror. It is reflected back along this direction. So is the wave direction, wave velocity direction changing? Is the wave velocity direction changing? Yes or no? On account of reflection, wave velocity direction is changing. It means that there is a phase reversal of 180 degree. You are moving in the direction of east. If you turn by 180 degree, in which direction you will be traveling? So the same thing, the wave velocity is directed onto the mirror. On reflection, the wave velocity is directed in your direction. So direction of wave velocity has changed. It means that there is a phase reversal of 180 degree. So in case of reflection of light, the phase reversal of 180 degree takes place. Now everyone has to make the use of compass box. You are having a plane mirror here. On this plane mirror, we are having an extended object kept here like this. Draw the ray diagram to find out the position of image. Draw the rays to find out the position of the image. Everyone must be able to complete this ray diagram. But to use it effectively to produce the image is a difficult task. I have been observing the copies and I observed that you are creating a lot of problem. What you are doing, you are not able to compare in a real life situation. So let us try to work on it and understand how the figures are to be drawn. Okay? Now this is the whole object, the AB has been shown here. Am I right or wrong? Am I right or not? Now you will observe that at A there is an arrowhead. So arrowhead is present in front of a mirror. So the ray of light from the arrowhead will be traveling straight onto the mirror. This is one of the possibility. This is one of the possibility, yes or no? Now we are aware that the object will be giving the light. The light will start from the object and will fall on the mirror. Am I right? Now if it is incident at this particular point, angle of incidence here will be taken as equal to 0. So angle of reflection will be 0. So ray of light will appear to you to be traveling in a backward direction, yes or no? Now, when a ray of light is traveling in a backward direction, we are aware of the fact that the ray is coming in a backward direction. So it appears to me as light travels in a straight line, it appears to me that with the same distance, if I call this distance as D, with the same distance D, I will be able to see that the light is coming from this particular point. Same distance you need, so I will be able to mark arrowhead here. Are you getting this? Are you all getting? Now, does it mean that I should always show the arrow in that manner only? I can have another ray of light that will be traveling from this point A and will be incident along this direction. Now with the normal, this will be the angle of incidence. So with the same angle of incidence, I will be able to show the ray traveling in this direction. This is angle of reflection, again equal. So the ray is getting reflected along this direction. So it should happen that as if the ray is traveling along a straight line from this point only. You need a scale to draw the straight line. So this is the point I am able to mark again. I can have here the ray of light incident from here onto this side. Can I draw like this? Can I draw like this? And again I will be able to show that this is representing the angle of incidence. Because angle of incidence is always measured with respect to the normal. So with the same angle of incidence, you will be able to show here, the ray will be reflected like this. Why I am rubbing it off, you are able to see that the angles are not equal. That is why I am rubbing it off. Now this will be the angle of reflection. So this line, if I extend it backward, it is the same point that we are looking at. Am I right or wrong? I can have one more ray that could be shown in between them so that we can check it out how it will appear. have drawn only for the arrowhead. I have not drawn for any other point on it. Now you can check it out. Whatever is the position of arrowhead, from different direction, I can make the light incident and see how the reflected rays are traveling. But all the reflected rays are as if coming from this particular point here. So the image of this arrowhead will appear at this point. So if I draw this particular line here, you will be able to show that this is the position of image. Are you able to get this? Are you getting me? How many rays can be drawn from arrowhead to the mirror? So choice is with you all. You have a choice how many rays are to be drawn. You ask me any number of rays, all the rays will appear to you to be starting from the image. Am I right or not? Because the light travels in a straight line, even if the reflected rays are not actually meeting at the point on the image there, but still they appear to me to be converging at the point where the image has been formed. And that is the reason we can show the figure in this manner. Able to get it? Now here we talk about the two words which are extremely important. We are talking about the word so do you see the image to be inverted or erect? Yes. So in the description of image, what you should write down? It is an erect image. Now I was observing some of the copies. I have seen that you have drawn the inverted image from a plane mirror. I don't want to blame anyone. Now just imagine, for a plane mirror giving you the inverted image, you are standing in front of the mirror and your image will appear to you inverted. You are standing in front of a mirror and your image is performing Shirsasana. Yoga class, nahi? Head down, legs up. Inverted image, are you able to see in a plane mirror or erect? So am I drawing the image in accordance with the reality? Can I take this image on the screen? Can I take this image on the screen? Boliye? There are again two words which we are normally referring to. So we are using the word real and virtual. So what type of image is formed in case of plane mirror? Real or virtual? Can I get the real image? How? By considering a virtual object, I will be able to create a real image by principle of. Are you getting me clearly? Are you getting this part? Now, there is one more term that is coming here that is called as magnification. Magnification means small m is equal to size of image upon size of object. So in this case, the size of image and object are equal or different? So magnification in this case will be taken as, right? Able to get this part? Now, for the plane mirror, which part is going to be more correct? So it is an erect image. It is a virtual image. And you are having magnification that is taken as +1 of equal size. So size of image is equal to size of image is equal to size of object. Now, is it necessary that I should only work for arrowhead? Or can I consider any point and draw the ray diagram? I mean to say that instead of going for arrowhead, if I consider the halfway point here, then first ray will be traveling from here to here. It will be reflected back along the same path as if this is coming from this point here. Barabar hai? I can consider another ray traveling from here to here. Again, it will be traveling somewhere like this, and you will be able to see that it is coming from the midway there. So every point of the object will follow the laws of reflection, yes or no? Getting it clearly? Sure? Any doubt now? Is the picture clear? How many of you have completed the ray diagram? Got it? Pakka? Okay. Now there is a second important task given to you. You are having a plane mirror like this. A letter A in this manner has been shown as an object. You have to draw the image of this. This is object. Use the ray diagram, use the concept of angle I equal to angle R and draw the diagram. Now at least you should be able to get this. Everyone is able to produce the image of letter A. Will it be virtual or real? Right? It will be a virtual image. When to call it real, when to call it virtual? See? Real कब बोलना image को? Now, why you are unable to get this image on a screen? Yes, it is inside the mirror. It is inside the mirror at the same distance. From there, you cannot take it on the screen. That is why, as the image has been formed inside the mirror, you cannot take it on the screen, and that is why we call it as a virtual image. Have you got the meaning of virtual? It's not real. It is well inside the mirror, that is why we call it as a virtual image. You cannot take it on the screen. Whereas in some cases, when you are able to get the image outside the mirror, then you can take it on a screen. Are you getting my point clearly? Then it will be called as a real image. Okay, so this is the case of virtual image. Is it erect or inverted? It is erect. So that is again true. The size of the image is? So letter A, whatever you have drawn, it is, suppose in a 3 lines you have drawn that letter A, then is it the image also in the 3 line formed or not? That you have to check it. Are you getting? The sizes should be the same. Okay? Now I want everyone to pay attention. You have got this particular part. Okay? Now, if suppose I take a black paper, listen to me carefully. I'm taking a black paper and I'm placing the black paper here in front of letter A. You can call it as obstruction. You can call it as screen. Or it can be a black paper. How will be the image? How will be the image? Draw it. How will be the image formed? Half of letter A, full of letter A, only the vertical half of letter A, horizontal half of letter A. I can go for infinite number of options. You have to decide what type of image will be formed. Lower part of? I am purposely taking it letter A because you should shout at me, A, tell the answer. So anyone? I don't want you to work on a judgmental level. Draw the ray diagram. Unless and until you draw the ray diagram, it is not going to give you the idea. Many times when I am talking to the student, I feel I am not talking to the student, but I am talking to the great scientist sitting in front of me. Because whenever a question comes, they start making a judgment. No, this is not going to happen. This is going to happen. Only lower part of A will be seen. No, only vertical half will be seen. A complete letter A will be seen. Judgmental. But if you are aware of laws of reflection, make the use of it and try to find out what would happen. Can I consider this as the angle of incidence? Incident ray. If I draw the normal here, this will be angle of incidence. With the same angle here, you will be having the reflected ray traveling along this direction. The ray would be appearing to you to be traveling from this particular point at the equal distance from here. So if I take this as distance certain, then equal distance would be somewhere here. So this will be the point of A. Am I right or wrong? So you were saying that lower half will be only seen. Mirror was? But I have not changed anything there. So this is very important for us to understand that even if 1/4 of the mirror is closed or half of the mirror is closed, the object will emit the light, will fall on the mirror, will not be visible for you in a particular position. Suppose I am standing in front of the mirror from here and somebody is putting a paper in between me and the mirror. But at a certain angle from there, you can see me. Like you are able to see at many parking places or turning points, there are mirrors used. So in front of mirror, if some obstacle is there, still you can see that. Am I right or not? And that is why this question is important. That even if you are painting half of the mirror with 50% blackened, still it will be producing the image. But how will be the image? Will the image of letter A be appearing to you as it is? Why not? Because every point, you can have the second point here, it will be having the ray traveling to this point. From here, it will be reflected by making the angle of incidence equal. So you will be extending that line here up to this part. So this letter would appear to you like this, somewhat like this. A complete image will be formed. Yeah? Along the length? No, that you are talking about equal distances, no? Size should be equal. Oh, yes, sorry. Something like this, okay? ये वाले रेट तो डायरेक्टली आप बता सकते हो ना यहां पर, राइट? बाकी के नीचे के लेटर्स तो रह गए, यहां से भी एक रे आएगा ना, ये रे भी बता सकते हो आप. बता सकते हो या नहीं? So will you be able to see the complete image, yes or no? Will you be able to see the complete image? Right? Huh? It will produce its own reflection, but we are looking at the object now, not at the obstruction. I have not asked you the question, what will be the image of the obstruction? If someone asks you what will be the image of obstruction, that will be there. Right? But complete image will be formed of a letter A, because every part of a mirror produces the image. That is why I have covered only half part, so that the remaining half part of the mirror can be used to form a complete image. Are you understanding it? The only difference with obstruction and without obstruction will be, with obstruction, the image intensity will be less. Because all the parts of the mirror are not producing the image. Only the lower half of the mirror is producing the complete image. That is the reason the intensity will be less. Are you understanding me? ख्याल में आ रहा है? Everyone is getting, yes or no? Now, what is this to be called? You are able to see that the longer line of length A is coming onto this side. What is this called? What is this called? Suppose you are standing in front of the mirror, waving your right hand. How does it appear in an image? So I am showing the same part here and asking the same, what you will call. When you wave your right hand to the mirror, the image will wave your left hand. Image will have the left hand waving to you. What is that called? What is that called? Real image. Mirror image. Have you heard about it? Lateral inversion. So the word there is lateral inversion. Laterally, along the horizontal side, there is a replica. Because suppose I am facing the mirror is on this side, I am waving this side. So my image, it will be producing the hand waving in this manner. That is why my right hand will appear to you in the image as a left hand. So there is a lateral inversion. Because of that lateral inversion, this type of letter A would appear to you in this manner. Able to get this? Any questions here? So now I am having a ball and I am keeping the ball in front of the mirror. Will the left side of the ball appear to you right side? So will the lateral inversion taking place? So for a symmetrical bodies or unsymmetrical bodies, lateral inversion takes place. Only we will not be able to see it. If you want to observe it, mark a point on a ball and then place it in front of the mirror. You are able to see the lateral inversion in ball also, which is symmetrical body. So lateral inversion is a common property of a plane mirror, that there will be a sides appearing to you changing from real object to the image there. Able to get this? Any question there? Getting how the ray diagrams are to be drawn? Now what happens in a book, if the similar figure is to be drawn, what they will do? What they will do? They will draw only two diagrams, two rays. Now, by drawing the two rays here, you start thinking that only two rays are to be drawn. And that is the reason I have drawn multiple rays starting from the tip of from the letter A. You can draw infinite number of rays. It's a choice of yours. But when you start drawing the infinite number of rays and you realize with the help of minimum two rays, you will be able to mark the image properly. Why you should draw more than two? Have you got me? For example, when you are taught about the 7 table when you were young, were kid, it was difficult for you to memorize. Then probably the teacher had taught you that 7 is to be added to 7 to get 14. So 7 2s are 14. So you were having 7 1s are 7. 8, 9, 10, 11, 12, 13, 14. Oh yes, 14. 14 is the answer. This is the way you are probably reacting to the situation. But today if someone asks you what is 7 2s are, what you will say? 14 without thinking, or 13. So my point is, by practicing number of rays here, once you realize how the image formation takes place, then you can restrict to only 2 rays. But minimum 2 are required. And every point on object act as a source of light. Every point on object will be emitting the light. And for every light emitted onto the mirror, you can have the ray diagram followed. This is the process of drawing the ray diagram. I think you have got the basic now, right? It will be helpful to us when we will be meeting for the next session, but this is required. One more thing. I have to explain you today. Limit theta tending to 0, sine theta upon theta. Don't forget. Even if I forget, you make me recollect. See you. Sai Ram.